Okay, now we're ready for problem 11. The next type of problem on this review are inverse functions. So basically, if you're given a function, they're going to ask you to find the inverse function. Now the first problem is they give you the function in the form of a graph. So they give you the graph of a function, and then they want you to determine what the graph of the inverse function would look like. So we'll do that problem in a minute. And then the second problem they have in this homework is they give you a function as an equation. Actually, I guess they have two problems where they give you functions as equations, then ask you to find the inverse functions. So we'll do the number 11 first, which is a graph. I will try and actually put the graph up here, and maybe I can zoom in and then talk about it. Let's see if this thing will focus. All right. So what they've done here is this line here that sort of goes back and forth is the actual function. And I'll explain in a minute how they actually draw in this straight diagonal line that sort of goes clear across the whole graph. Because what happens is, when you have a graph of a function, there's a very quick and easy way to find the graph of the inverse function. And just so you'll know, I can write it here. Here's like function notation, f of x. Inverse function notation, you put a -1 here. Now that does not mean an exponent of -1. That -1 is just the way that they use to designate an inverse function. So in a sense, this graph here is a graph of a function f of x, and they want us to now figure out what the graph of the inverse function would look like. Now in this case, it's very simple. When you have a graph of a function, if you want to find the inverse function, all you have to do is you draw in this line here, and actually this line is the line y equals x, but it's pretty much just a diagonal line that splits the first quadrant right in half and also this third quadrant. So it just splits it perfectly right down the middle. And then what you do is you take whatever your function is, and in a sense you rotate it around this diagonal line. So if you can imagine this graph here, if it's sort of flipped over on the other side, what would it look like? And of course, on the actual test, it's multiple choice, so you don't have to actually draw it. But let me just kind of draw it in so you can see how it happens to visualize it. So it's probably going to look something like maybe so can you see that? We're basically here on the sort of upper left is the original function. If you take that and rotate it around this diagonal line, it ends up looking like this. So then all you do is then you go to your choices, and we're going to look for a graph like this. So it's pretty easy. Obviously A, this is the graph of the inverse. That's not correct. B, that pretty much looks correct. Just to see the rest of them. C, Here's your original function, and then they say the inverse is like this. And then D is a little bit closer. The original function's here, but you can see it's not really correct. So obviously B is the one. You can sort of visualize it where you take this graph on the top half, and if you rotate it, so the answer is obviously B. Not very hard. So now we're going to go to problem 12. And problem 12 is where they give you a function, but the original function is going to be, sorry, this camera, I'm trying to get the zoom back to what it should be in it. Alright, let's just go right there. I may have to change the focus. Alright, so problem 12 says the function f of x equals and they say this is a 1-to-1 function. 1-to-1, I don't have the time to explain to you now, but 1-to-1 function basically means if you have a function and then you find the inverse function will also in fact be a function. Alright, once again, I don't have time to explain it now, but we use the word function in math a lot, but there's a formal definition of what it means for an equation or a graph to be a function. So f of x, we call this a function, but really it's actually a formal, actual defined function. And if we go find the inverse function, because we're told it's a 1-to-1 function, we know the inverse function is also a function. If it's not a 1-to-1 function, sometimes you'll have a function, but it's not 1-to-1, which means if you go find the inverse function will not be an actual function. Unfortunately, I don't have time to explain all that. That's something in a face-to-face class we take a half-hour in class to explain, but hopefully you read about it in the book and you understand it. So basically, this problem is find the inverse function and then find the domain and range of f. And so multiple part problem. First, they want us to find the inverse function, and then after that they want us to find the domain and range of the original function and the domain and range of the inverse function. So let's find the inverse function first, and then we'll worry about the domain and range. When you're given an equation, finding the inverse function is pretty straightforward. 4 pretty simple steps. The first step is simply notation. I'm going to go ahead and replace f of x with y, which we do all the time, you know, but I'm going to go ahead and actually state it. So now I'm going to say y equals 5 over 9 plus x and what I'm going to do is I'm going to swap the x's and the y's. Every place we have an x, I'm going to replace it with y, and every place we have a y, I'll replace it with x. So this is y, which becomes x equals 5 over 9 plus, since this was x, it now becomes a y. So that's not too hard. Third step can be more difficult, still according, because now we're going to solve for y, which basically means here's my expression I want to get y equals something. Get y by itself on one side. So now this involves just some algebra. So for instance, 9 plus y is on the bottom. I'll multiply both sides by 9 plus y. And you get x times 9 plus y in parentheses equals 5. Now to solve for y, let's go and multiply out the parentheses. If I want to solve for y, what I'm going to do is I'm going to get all the terms with the y on one side and all the terms without a y on the other side. So I'm going to move this 9x to the other side. So I'm going to subtract 9x from both sides. xy equals 5 minus 9x. And now if I want to get y by itself, divide both sides by x. And now I solve for y. I can just leave it like this. And then the fourth step, once again, it's just notation. I'm going to now take the y I just solved for, and I'm going to rename it the inverse function of x. So once you solve for y, what you really have now is the inverse function. Now the rest of this problem deal with domains and ranges. Domains we've talked about before. Let me just go ahead and let me rewrite the function and let's talk about domains and ranges. The domain are all the possible values of x. So what I always teach is the domain, when you start out with an equation, you just assume the domain is all real numbers. And the only time that's going to change is if you have any variables in the denominator or variables under a square root. And I look here, turns out we do have a variable in the denominator. Once again, the thing we have to avoid, we can make sure that the denominator, we have to make sure that the denominator can never equal 0. So I know x cannot equal minus 9. So the way on the computer, the way they want this notation, this is sort of a fancy math way of writing the domain. This is another way of saying the domain is all real numbers except negative 9. That's why they're not equal to negative 9. Let me write the domain of f of x. The range are all the possible values of y. Once again, if I rewrite this as y equals 5 over... Range can be a little tricky because you just have to sort of in your mind think about what's going on here and think about, are there any numbers y cannot be? I mean, can y be negative? Yeah, y can be negative because if I make x a big negative number, the whole thing can be negative. Y can be big, it can be small. Actually, there's only one number it looks like y cannot be, and this is a little tricky, but it's not possible. Y is never going to equal 0. Do you guys know why that's true? got a fraction here. The only way a fraction can never be 0 is if the numerator or the top is 0. But in this case, the numerator or top is a 5, and it's just a constant. It's always 5. So the numerator is never going to be 0. So therefore, this whole expression will never be 0. But other than that, I think any other number you can think about, y can be equal to that. So I think we'll say for the range, I think we just say all real numbers except y equals 0. Now what's interesting is now they also ask for the domain and range of the inverse. What's nice is let me just write these out, because once I explain to you how we're going to do this, it's going to go very fast. The domain of the inverse function actually is equal to the range of the original function. So it would be this right here. And the range of the inverse function is equal to the domain of the original function. Up here is the domain of the original function. That is also going to be the range of the inverse function. So they just flip, they just swap. So that's sort of nice. Now actually, problem number 13 is almost the same as the problem I just did. So just to save time, I'm going to skip it. There's nothing new. Just so you know, the problem I was given is f of x equals 3x over 8x minus 1, and you're asked to find the inverse function, and then you have to find the domains and ranges, and you do the same thing, the same 4 steps to find the inverse. Just the algebra is a little bit different, but I won't take the time to do that. I won't waste my time or your time, either one. So those are the problems on inverse functions. On the next video, we finally now get to exponential functions, and then eventually log functions, and then that should be pretty much it for the information on this final exam. So next video we'll pick back up with problem 14.